Histograms are a very common and very important method of visualizing data. So what you can see here at the top is we have random variable L, and random variable L is a data set composed of what appears to be continuous datums. These datums are continuous because it looks like they're measured, and I can tell that they're measured because of these decimal places of accuracy. This histogram down below is a histogram of this random variable. Uh, these three dots here in the middle just means there's a lot more datums, okay, in between these. So this is just showing some of the smallest datum values and some of the highest datum values. So this datum value here would be the minimum value, and this one would be the maximum value. And so out of all of these datums, they were separated into 10 classes, each class being 50 wide and starting at 0. So these parameters actually kind of describe how this histogram was constructed. So if we look at the starting point of 0, we can see here at 0, this is where the histogram starts. That we've got 10 classes, that means we have 10 of these histogram bars. So here's the first one. Do this a different way. So here's the first one, the second one, the third, fourth, fifth, sixth, seventh, eighth. So there's ninth, even though there's nothing there, and then the 10th. So we've got 10 classes or 10 bars, and each one is 50 wide. So here, this first class goes from 0 to 50. So that's a width of 50. The second one goes from 50 to 100. Again, that's a width of 50. From 100 to 150, that's the width of the third class. And then the fourth class is 50, 50, 50, 50, 50, 50, and 50. So with a histogram, you need to have a starting point. You need to determine how many of these classes you're going to have, and you need to figure out how wide the classes have to be. Now notice the widths are all equal, okay? And so choosing the number of classes and how wide they're going to be, you need to design that so that it encompasses the full range of your data. Now, what do I mean by the full range of your data? Well, notice that the maximum number here on our histogram, 500, is just a little bit larger than our maximum value, which was 496.6. And this value of 0 on the left-hand side of our histogram, that is lower than our minimum value. So you can kind of see that the bounds that we have here in our histogram are designed to contain all of the data in our data set or in the random variable. So all of this has to be designed, has to be prepared with care. So you have to do all of this with intention. Now you can use your calculator, you can use software programs, spreadsheet programs to make these histograms for you, but the histograms they make are just going to be made with whatever parameters that they want. And it's most likely not going to be aligned with what you need. So you need to understand, what you're doing so that you can control your calculator, you can control the spreadsheet software to generate the histogram that you want intentionally. So let's kind of maybe break down, the anatomy of a histogram. And this goes with just all the things that I've just talked about. So, each of these bars, okay, we call those classes. Some software packages call these bins, and a bin is a good word. It brings to mind an analogy that is actually helpful, but we'll get into that in a minute. Each class has a width, so we call that the class width. And notice that the class width is always the same. We need a starting point. Okay, so the starting point is the leftmost part of the histogram. And each of these classes has what's called a lower bound and an upper bound. So the lower bound of the first class is your starting point. And then you've got the upper bound. Now, the upper bound is just going to be the lower bound plus whatever width you have, and that gives you the upper bound. So, for example, in the last example, our lower bound was 0, and our width was 50, and 0 plus 50 gave us the next tick mark here, which was itself 50. Okay. So you can get the upper bound just by adding the width to your lower bound. And each class can also have its own midpoint. And so the midpoint is just the average of the lower bound and the upper bound for that class. So you just add them together and you divide by 2. Now, another point of interest here is notice that I've got this little subscript 1 here next to the upper bound, and I have a different subscript 2. And that's because you'll notice that class 1 and class 2 actually share a boundary. Okay, they share a boundary. And so the upper bound of class 1 is the lower bound of the next class, class 2 in this case. And so notice that this pattern kind of replicates throughout the rest. The upper bound of class 2 is equal to the lower bound of class 3. The upper bound of class 3 is equal to the lower bound of class 4, and so on until the end. And this is all well and good, but this can create some confusion when designing your histograms. And we'll kind of get into that here in a minute. The one thing that I didn't put in here is that, this lower bound here and this final upper bound of your final class, this has to encompass the full range of your data set. And this is kind of what I highlighted up here in yellow when I highlighted 500 being greater than our maximum and 0 being lower than our minimum. Okay, the histogram has to encompass all of our data in order to be, a credible, consistent representation of our data. So this horizontal axis here, is going to be in the same units as our random variable. So for example, up here, each of these measurements were in nanometers. And you'll notice here that I labeled this horizontal axis in units of nanometers. Okay, so the horizontal axis will have the same unit of measurement as our datums in our data set. But the vertical axis can be in 2 different scales. Here I put frequency. And so frequency is the number of times that something occurred. But you could also represent the vertical axis not just as frequency, but as relative frequency. And if you do it in relative frequency, that'll be a number between 0 and 1, right? 0 being like 0% and 1 being 100%. So, you could have this vertical axis being from 0 at the bottom to 1 at the top. In the middle would be 0.5, and so on. Okay, so this is the general picture of a histogram. And when we're designing histograms, I'm going to be saying, well, the number of classes is going to be 7. The class width is going to be 4. the frequency is going to be 13, and then it's going to be 15, and then it's going to be 10. The lower bound of class 1 is this. The starting point is that. So these are all the terms that you need to become familiar with in order to paint this picture in your mind ultimately. So once you have, your given data set, I kind of like call that step 0, is having your data set, knowing how many datums you have in your data set. Do you have a sample size of 50? Do you have a sample size of 103? Knowing something about your sample size, and also knowing how many decimal places are in your data. I call that step 0. Okay, that's just kind of starting with what you can see. It's what you're given at the beginning. Step 1 in designing histograms is to figure out your starting point. All right. And so here's that picture of the anatomy of a histogram. And so we need to figure out where exactly we're going to start this histogram. And it's from here, this starting point, that everything else kind of follows. We'll determine a width. We'll determine how many of these bars, how many of these classes we're going to have. And then we need to figure out, the lower bound and upper bound for each class. Now, what makes teaching histograms difficult from my perspective, and maybe difficult from a student's perspective, is it would be nice if every calculator and every software package, drew histograms exactly in the same way. Unfortunately, that's not the case. And therefore, I need to kind of teach you the subtle ways that calculators and software packages design these histograms, because in this class, you're using different calculators, and for your project, you'll be using different software spreadsheet programs. All right, so I need to kind of prepare you for how all these different, histogram making options format their histograms. Okay, and so namely, the Texas Instruments calculator, the NumWorks calculator, and the online homework system defines classes with this interval notation. So a left bracket for the lower bound and a parentheses for the upper bound. Contrasting with the calculator and the online homework, we have Microsoft Excel. And for Microsoft Excel, in the first class, it has a left bracket for the lower bound and a right bracket for the upper bound. And class 1 is just different in Excel than class 2, 3, and 4. The lower bound is a parentheses and the upper bound is a bracket. And it kind of repeats that pattern over and over and over again, like that. For the calculator, if I may backtrack a minute, it'll be left bracket, right parentheses, left bracket, right parentheses, left bracket, right parentheses, and so on. Now, Google Sheets, which is, another spreadsheet software that competes with Microsoft Excel that some of you may be using, the first class, instead of having a left bracket, actually starts with a left parentheses, and the upper bound is a right bracket. Okay, it's opposite that of your calculators and different from Microsoft Excel. And each class just continues to follow this pattern. Left parentheses, right bracket, left parentheses, right bracket, left parentheses, right bracket, and so on. And then on top of that, your textbook, the OpenStax textbook uses a different method where it uses left and right parentheses only. Okay, so you got left and right parentheses, left and right parentheses, left and right parentheses, and so on. I've used this in the past, but I think this is going to be a little confusing, so we're really not going to be using this method. You'll just need to pay attention to the fact that you're using your calculator, and this is how your calculator designs histograms. But you're going to need to pay attention, depending on which spreadsheet software you're using, how each software package designs its histograms. Okay. Now, Here I'm talking about left brackets and parentheses, and some of you may be thinking, well, what does that refer to? What does that mean? And that refers to what's called interval notation. Okay, so interval notation is a shorthand way to define a range of numbers using inequalities. So if you have like a greater than and less than, you can represent that with parentheses, like a left parentheses and a right parentheses. If you've got greater than or equal to and less than or equal to, then you can represent that with a left bracket and a right bracket. So, for example, if this first class up above, sorry, had a lower bound of 42 and an upper bound of 46, then you would just kind of translate that down on your calculator, and you would have left bracket 42, comma 46. Microsoft Excel, you'd have left bracket 42, comma 46. And let me skip Google Sheets for now. So when we come down here, we can see we've got left bracket 42, comma 46, right parentheses. And what this means is this means all values of X are all datums that were greater than 42 and less than 46. So greater than or equal to 42 means that 42 is included, but less than 46 means that 46 is excluded from this interval. And so this is how the Texas Instruments and the NumWorks calculator kind of interprets its intervals. Next would be Microsoft Excel. So Microsoft Excel, if you remember, uses brackets. And so this means datums that are greater than or equal to 42 and less than or equal to 46. And that would include datums that are 42 and datums that are 46 would be included in this interval. Now, I kind of skipped Google Sheets, and let me explain why. So notice here that that if we decided to use 42 and 46 here for the interval definition of our first class, where would a datum, so let's say we had a datum that was exactly 42, where would it go? Well, where would it go if we were using Google Sheets? Well, it wouldn't work to go into class one because of the way class one has been defined here, because that left parentheses means that it's greater than. So if class one was defined to be greater than 42, then this datum wouldn't fit. So what we need to do is we would need to go a little bit lower which is what I did here. And so this datum of 42 would fit in this interval because 42 is greater than 41 and it's less than or equal to 45. So this parentheses, means that whatever value is next to the parentheses is excluded and whatever value is next to a bracket is included. All right. So, I've been talking now about classes and intervals, and I just now talked about how the datum 42 would kind of fit in an interval, and all that's rather abstract. So let's kind of pull back a little bit. Let me give you a little bit more of a concrete example about the relationship between datums and classes by using an example of trash and a recycle bin. Okay, maybe I should put it here. Trash and a recycle bin. So think of, trash, let's say all of the trash here, all of the trash, that would be your data set. And each of these little items here in your trash, each of these is a datum in your data set. Now, when it comes to trash, we know that we need to classify the trash, and we need to classify the trash into different recycle bins. So, we could have a recycle bin for glass. So we'd look through our trash items and find ones that appear to be glass, and then that'll go in the glass recycle bin. Then we would look at the next recycle bin, which is paper. And then we would go around looking for bits of trash that look like they're made out of paper, like that. And we'd put only the paper items into the paper recycle bin. And then next, we would look at the next recycle bin, and that's organic. So now we would look for trash items that look like they are organic trash, and only those will go in the organic bin. Okay, well, the same is true for histograms, except instead of having recycle bins, we have classes. So this would be class 1, class 2, class 3, class 4, class 5. And what defines each of these classes is going to be whatever interval is around it. And what you do is you take a datum, that's in your data set, and you see whether that datum fits in this class, or if it fits in that one, or that one, or that one, or that one. Then you go to the next datum and you see where it fits. You go to the next datum and see where it fits. So that's essentially what we're doing here with datums in a data set. And this is how we begin to build up the frequencies in each of these classes. So let's look at an example here. So here we've got a data set which represents milligrams of tar in cigarettes from 44 non-filtered cigarettes. So we've got 44 datums in this random variable T, which stands for tar. And each of these numbers represents milligrams. Now, down below, we've chosen 42 to be the starting point. And what is the width of each class? So, here we've got these dashed lines to represent class boundaries. And the difference between class boundaries is going to be our class width. So the difference between 42 and 46 is going to be 4. And the difference between 46 and 50 is 4. So notice that the difference between boundaries is all the same. This is our class width. All right. And then how many classes do we have? So how many classes do we have? Well, we've got 1, 2, 3, 4, 5, 6, 7. So we have 7 classes. And we use like an uppercase K to be a variable that represents the number of classes. So we have 7 classes, and each class has a width of 4. All right, that's what we're looking at. That's great. But now we need to figure out, which data points are going to fit into which class. So let's say that we were creating this histogram using your graphing calculator. Then this first class here we could define this first class using this interval notation, which is left bracket, right parentheses. Left bracket means it includes the value that's put next to it. So this interval would go from 42 to 46. So what this means is that we're going to include 42. We're going to choose every number that includes 42 but excludes 46. So let's look back up here at our datums in the data set. And so 42 would be included in that first class, as well as 43. Now we have a 46, but remember, 46 is excluded because of this right parentheses. Okay, this right parentheses here means that it excludes 46. So in this first class, we are going to have a frequency of 2 because there's only 2 datums that are actually going to fit in this first class. All right, let's define class number 2. So it's going to be left bracket, right parentheses. And now it's going to go from 46, and then we're going to add 4 to that, to 50. So remember what I said earlier, that 2 classes share a boundary. And the lower bound of class 1, the upper bound of class 1 is equal to the upper bound of class 2. So that's why 46 appears twice. 46 is the upper bound of class 1, and 46 is the lower bound of class 2. Now, this says that the second class is going to include 46 and every datum up to 50, but excluding 50. So if we come up here to our list, we're going to include 46 and every datum up to, but excluding 50, which is going to be right there. So we're going to include 46. We've got 3 47s. We have a 48 and a 49, but we're not going to include 50. So what's the frequency of our second class? We've got, let's see here, 1, 2, 3, 4, 5, 6, 7. So our second class has a frequency of 7. All right, let's look at the next one. So now we've got class 3, and it's going to have a left bracket and a right parentheses. And the lower bound of class 3 is equal to the upper bound of class 2. So it's going to start with a 50. We're going to add 4 to that. So that's going to be 54. And now we want to look at datums that include 50 up to, but excluding 54. So we're going to include 50 and go up to, but excluding 54. And if we look at this, dot plot of the data, we're going to include 50 and all of the datums excluding 54. So how many do we have in the third class? We've got 1, 2, 3, 4, 5, 6, 7, 8. I think that's 8. So the frequency of the third class is 8. All right, so let's do the next one. So we'll have 54, add 4 to that, 58, right parentheses. So let's see here, we're going to, let me erase these, okay. So we're going to include 54 and every datum up to 58 and excluding 58. So 54 up to, but excluding 58, like that. So it's going to be including 54, 55, 56, 57, but excluding 58. So what's the frequency of our fourth class? It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. So you can see now we're just going through the process of taking these datums and figuring out which class they fit into. And then, depending on how many are in that class, that defines our frequency for that class. And that's how up here, with my first example, I had a frequency, I think that's probably 12. And here's a frequency that's almost 70. And here's a frequency that looks like it's about 90. This one could be 89 or 88. This one looks like it's maybe somewhere around 35. Okay, so that's how you set the heights of each of these classes, is just by counting how many datums fit in each bin or fit in each interval. Now, if we were going to go through and do this with Microsoft Excel, we'd kind of go through the same process. But what I want to do is I want to point out what we need to do with Google Sheets, because how Google Sheets sets up its first classes is a little different. So here, class 1 does not include the first number in the interval, but does include the second number in the interval. So if we were to put 42 and 46 like this, like we did with the calculator and like what we would do with Excel, this tells us to not include 42. So if we were going to try and do the same thing that we did earlier, then here where it says do not include 42, well, that means we're going to not count this datum. And then we would only end up counting this one. And so we would have a frequency in the first class of only 1, but we're excluding a datum. And you can't do that. We have to make sure that we include all the datums in our data set in the histogram that represents it. So we can't use 42. We're going to have to choose a number that's a little lower. And so we'll have to go a little lower and make that 41. So our starting point, if we were using Google Sheets, wouldn't be 42, it would be 41. And by choosing 41, now we're going to have values that are greater than 41. But actually, we want to have a width of 4. So then this upper bound in this class would have to be 45. So we're going to have datums that are greater than 41, but less than or equal to 45. So that would include these two, but it would stop here at 45. And then that would end up giving us a frequency of 2, because that would include these two datums right here. And then we'd go through and just keep defining the rest of the classes. So left parentheses, right bracket. And we'd have 45 and add 4. That'd give us 49. So now we want values that are greater than 45 and less than or equal to 49. So let's see, here's 49. So now we want values that are greater than 45, which would be this one, these ones, this one, and less than or equal to 49. So that would include those. So the frequency of the second class, if we were using Google Sheets, would be 1, 2, 3, 4, 5, 6, 7. That 2 would be 7. And we would just keep right on going. Left parentheses, right bracket. 49, because it's the same number there. Add 4, that would be 53. So here's 53. And now it's going to be values that are greater than 49, but less than or equal to 53. So values that are greater than 49, so that'd be starting here, and less than or equal to 53. So the frequency of the third class would be 1, 2, 3, 4, 5, 6, 7, 8. All right. And we could just keep going. But I think this is enough to kind of make the point that depending on whether you're using um, the graphing calculator or Microsoft Excel versus using like Google Sheets, you're going to have a different starting point. And it is possible that because you have a different starting point, you might end up with different frequencies here in the classes. All right. They happen to be equal in this example, but it's possible you could end up with a histogram that looks a little different, depending on whether you made it in Excel or you made it in Google Sheets, and you therefore had different starting points. All right. So lastly, the thing to talk about is we did, kind of like all this designing, but all of this designing was based off of having 7 classes that were 4 wide. Well, what would this histogram look like if instead of having 7 bars, what if we had 6? And if we had 6, then they would be 5 wide instead. So what would that histogram look like? And so that's part of the reason why, you're learning about how to design histograms, because there's a lot of factors that come into play when you're designing them. Okay, so this is a good place to stop. I think this kind of adequately gives a good definition of what a histogram is, all of its individual parts, how each of those individual parts are defined, and how, you start with data. You start with data and you end up funneling that into the different classes and so on. So I think that's a good place to stop here. Feel free to ask me any questions.